Guys, Adam from iClimate. You're joining me on an evening time. It's about 6 o'clock. Everyone's gone home. Next to a 20 horsepower condensing unit that I'm just about to put under the first pressure test to see if there are any leaks. 15 indoor units, heat recovery, 20 horsepower Daikin VRV, BS boxes, 3-phase power supply, all ceiling cassettes, multiple of press fitting we've used as well to prove the press fits do work and they are reliable, along with all the welding. We've just finished piping up the main branch pipework to this condensing unit, but we're just a bit behind schedule. We should have pressure leak tested it maybe a few days ago, but this project started really well. The client, they notified us that, they wanted to make 2 smaller offices on the floor, and then 2 smaller offices meant the air conditioning indoor units that we'd sent already couldn't be used because they'd be oversized. We started putting all the units up by day 2. We had 15 indoor units and 15 BS boxes in their locations, and I started to run the main branch pipework into the building. But as you know, talking to the manufacturers, we had to change the pipe sizes. So a lot of the work that we did had to be redone. But hey, big projects, everybody thinks they're big money, but they are big headache as well, and ruin the screws. And everybody will know when you have Daikin on site under a warranty claim, they will count how many screws you have in your cover and why you don't have those screws. So please, as you can tell, it's a standard doorway. This unit would not fit in a standard doorway. So we didn't get a crane here, so we just had Daikin do a strip and rebuild. Service means the unit arrived in sections, and then they brought it through here, and then they built it back up. Okay. So, first time about to pressure test. For the testo guys, yes guys, I've had testos over the years, but I tell you what, about 14 years ago, I bought a field piece refrigerant scale from America, Field Piece America. And that thing has taken a battering in my van and numerous vehicles, and it's still solid. And I thought, let me try their gauges, because I like the fact that they have a very large display, and it's very clear. Where's my JVAC gauges? The days where colors just go with colors. Gone are the days where they used to blow condensers with R12 and then wonder why they got dusted, the dust attracted to the oil. All right, so, I have an issue. Do I have an issue? No, I don't. Oh. For a second there, I thought they were smaller. They were not 410A. This is a 410A system. They can still make large VRVs with 410A. Right. The new refrigerant's R32. We have a lot to say about R32. It's supposed to be better for the environment, but as far as working on it and systems, it's a very temperamental refrigerant. Okay, so liquid line, 3 pipes, the heat recovery. Liquid line, that's warm liquid, yeah. Fed into the indoor units or to the BS boxes in this case, right? Middle line is a suction line, that's a return, that's a superheated refrigerant vapor returning to the compressors. And then our last pipe here, the additional pipe on the conventional air conditioning unit, is the hot gas discharge. So this is for when the inside units need heating, and it will send the hot gas to them. And then the hot gas will go into the inside units through the BS box. And then once it goes through the indoor units, the fan then obviously condenses it down, and then that will return back to the BS box in a liquid. I'm going to start with the liquid line. Reason being, it carries liquid, it's going to be hydraulic, so it's going to actually, from a scientific point of view, the pressure, it's going to be equivalent to the same of the gas. Liquid always, because there's a different state, it's not gas, it will still have more stress because it'll have to naturally expand. There we go, R410A. So this is like our testing gas, so it's called OFN, it's oxygen-free nitrogen. And it's oxygen-free because moisture is an enemy to refrigeration system, because we're dealing with manipulating the refrigerant at very low pressures and temperatures. Any moisture or contaminant will just freeze and literally turn to ice within the pipework or within the system, and then cause blockages and issues. There's also tracer gas, which we use as well. But that's more of a secondary procedure when you can't find a leak through numerous pressure tests. Okay, so we have regulator attached to there. Guys, be careful with these bottles. The safest way is put the bottle on first, always work from one point. Then I turn that valve off because I want to make sure that valve's okay. Valve works, you can hear the noise, then purge the line, close, turn that up to 20 bar. There's two ways to do it. You can do it how I'm doing it when you want to actually check the physicality of the pipework quickly and rule out there's any leaks if you're on a project that's behind. Or you can wait till all the power supply is done, units on, you can address everything, and then you can put the unit in a evacuation mode, which is 21, set 21. The Dakin guys will know this. That basically means it'll open up every single valve within the system and the BS boxes, ready for evacuation or testing. But I don't have time for that, so I'm going to rule out tonight whether there's a leak or not. So tomorrow the guys can crack on. We are testing the condenser in the same state it arrived from the manufacturer, with the service valves fully wound in and closed. Suction valve goes on. That's the pressure in the PSIG. That's the gauge. And you'll see that's the evaporating temperature in accordance to the pressure for that refrigerant. So all these machines now have these built in. We're not going to be surprised if we see any pressure dropping either, because we don't know what the state the valves are in. There's a lot of valves, BS boxes. Jump to 30 psi, so it's moving out somewhere. Could be equalizing, could be a leak. So what I'm going to do now, it's only at low pressure. I'm going to leave this on. Make sure the bottle's upright and safe, and no one's going to knock it over. I'm going to go for a little walk inside. Oh guys, it's not one that I brazed. Yep, it's not one that I brazed. Yeah. Okay, so we have some welding to do. Another leak. Another one here. Oh, lovely. So I've identified two leaks on the floor. One on that side on the BS box main branch. You can hear it. And one on the BS box outlet to the fan coil unit. Identified a second one. I'm going to let the system drain down now, empty it, re-weld them quickly, put them on the same test and rule them out, and then we're going to build the pressure up one by one. Okay. So my plan was to put a bit of gas down the liquid line with all the power off on the boxes to see the state of the valves as they are in the BS boxes, whether they're closed or whether they're open. That clearly shows to me that the liquid line valves in the BS box are open. That's how the gas has got through here into the fan coil unit, heat exchangers, and then leaked back here out. So that proves the state of Dakin BS boxes when they're shipped from the factory without no power. But I'm still gonna rule some things out. So let's try and weld this leak up. The pinhole is actually there. I take my words back for the first time. Don't put that on camera. It's a weird one. Particularly a pinhole leak with a clear pinhole at the back of the crimp here at the top. You can't see. Yeah, good. Yeah, the pinhole is right there at the top. There. These are not my welds, these are their welds. Done. Let's go put it under pressure. Take two. Now I'm putting it into the low side, and it's also reflecting to that. So there's a clear pathway of all the valves being open from the liquid line here, and all the way through the BS box, and then back round. But which BS box? We've got a few, we've got 15. We don't know which one could be set up as passing or which one couldn't. But the way it's reacting very quick is it feels like the entire, all the valves in the BS boxes are open because it's equalizing very quickly. So I'm gonna go back to putting it down the liquid line. Keep an eye on that suction is creeping up. That's showing me the true pressure in there. That's showing me the pressure that I'm pumping in there. Again, by doing it this way, we are ensuring that the nitrogen that we're pushing through the small pipe, the liquid line, is also stage by stage filling up the entire larger pipework, the suction run, and coming back to the condenser. It's just a bit of a more methodical way to pressure test. You'll see that's equalized out now, 100% right. Trickling in here, 33, 14, and we're going to take a walk inside. This is actually safe to leave, and see if as the pressure's building up, if we can hear anything before it leaks again. Nope. Yep. Same one. Yep. Did I weld the wrong pipe? I welded the wrong pipe. I welded the wrong pipe. Sometimes when you're working under conditions like this, where the guys are wearing headlights or torch lights and it's not lit, it's in the bulkhead, the solder may seem like it's gone through, and you can actually tell it, the black side, which is the solder penetration in the copper, that's actually gone through into the collar, but it's very small air gaps, or sometimes when the welds are fusing together with the copper to copper, even when it's cooled down and it may look like it's closed, you'll get a tiny pinhole. That's not even a millimeter. And sometimes won't be seen to the eye, because of the high pressures of the refrigerant. See? And that's making that noise with only like a PSI above atmospheric pressure. So what happens is sometimes when, it's not because there's a lack of solder or it's incompetency brazing, it's just sometimes when the solder is too excessive and the nitrogen that's been pushed through the pipe sometimes can cause small capillary pinholes through the welding of the material. So it might look like a good weld. I didn't actually add any solder to those welds, I just heated them up. So you can see now there's a substantial difference between the pressure, and it's taking longer to equalize, which means that the leak that was happening was basically forcing it to equalize quicker by leaking out to the atmosphere. So I can see by the way it's equalizing, that's more in time. Yes, perfect. See? Yeah, definitely within a minute it's equalized. Not even. Now if this continues to drop lower than that, and that means that the pressure here is still equalizing across here. But these will now equalize, and then when they come down together, that'll indicate a leak. Yep, so this is 21.9 psi on the high side, one side, and 21.5 psi on the other side, above atmospheric pressure. So that's the psi, it's above the 14.7, which is standard atmospheric pressure at sea level. And that's not budging. So that's giving me an indication that this system is, at this stage, is airtight. We have no other leaks in this system at all. So ideally, I don't even really need to walk around after about 10 minutes of sitting here. I can pretty much rule out that nothing is leaking drastically. Let's do a little walk around. We have a couple of PSI there. So the 2-inch pipes that run into here, the suction, the hot gas, you'll see we haven't lagged the, see those are the large pipe work and the brazes that I brazed on the welds, and they're all fine. So this is the ground floor, the server room. Pipework then comes down into here, and it comes down into here, and then I've bent it across and up and out from here. And that's 3 sets of pipe. You can imagine how tricky that was. As you can see, it's a very, very large to be. As I'm happy with that, it's 63.9 and 64.3. There's hardly nothing into it. I'm going to ramp this up in stages now, and the remainder of the job I'm going to film once we get operational to show you the units working from my phone. Hey guys, Adam from iClimate on site. It's Saturday. That noise you can hear, excuse it, is the nitrogen being drained off. You remember from the last video that we filmed on site, we were pressure testing. Now the pressure is being drained. We're doing our 3-phase power supply to the unit. It's raining outside, so we threw a bit of tarp on it. Can't get wet. Isolate is going to go there, and our electrician is on site today to do his testing. I'll show you onto the floors. Excuse the darkness, there's no power. We've isolated the power. So yeah, the floors are quite tidy, all the units are up. Here's some of the pipe work that we ran. You can see it's all been lagged and strapped. BS boxes, we've left the covers off. And I'm gonna go around today, pull a vacuum on the system, and then once a vacuum is pulled, we're happy with the tour. We're gonna do our testing on our power supplies, and then I'm gonna be doing a walk around measuring the length of the pipework, especially the liquid line, so that we may put the right amount of refrigerant in with the VRVs. So I'm here commissioning the system. I did a small snippet last time, you showed you the pressure test, and then now I'm gonna show you the charging, right? So the unit's there, it's passed the pressure test. I'm putting in some trim refrigerant to it. See, I've got it on my phone. It's the wireless scale. These are my gauges. I'm throwing in some liquid 410A down the liquid line first, and then down the suction. And then I've had the compressor, the condenser sitting with the power on, so the crankcase heaters. Charge it up to 13.4 kg. That takes the system to a total charge of 25.2 kg with 11.8 base charge in there. I'm just going to do the wiring and piping check. I've walked around all the fan coil units, just do a small little check, and then we're going to fire it up and then see the heating and cooling simultaneously. Right guys, just moved on to the testing of the refrigerant. Compressor started up. This is the virgin start of the VRV. You hear the compressors. Gauges are on. Function is TO2. You can see that on the segment. So what this allows me to do is to add the refrigerant that it needs for the additional pipe work into the system. TO2, compressor starting. We have 120 psi, 100 psi low, 225 on the high. It's in cooling mode. Air off is warm. Hot gas is not running. Suction is that. 85. Liquid is warm. You have the refrigerant going in. Be careful not to overcharge the system into the low side where the low pressure is to draw the refrigerant in, as that will then send liquid back to the compressor, and our compressors are not hydraulic. They are air pumps essentially, not hydraulic pumps, and they will actually, once liquid goes into the compressor, it will then cause a variation of problems for the compressor and the motor. So A, too much resistance, draw more current. B, liquid could get into the sump and overload the duty of the crankcase, or the crankcase is sized for, and then that would then push the oil out of the compressor, seizing the compressor, and also, like I said, if there's excessive liquid coming back to it. Yeah, this is cut out on 0.50, the safety protection. I'll turn that off and reset it. So I've got the condenser running, that's the noise of the compressors, put the cover on, got the condenser running on a forced cooling mode for gas charge. It's a bit low, 4.2 bar. Throwing some fridge in there. I need to hit another 3.5 kg. I've got 2.6, another kilo to go. Put my probes on it a bit later. See what it's taking out. I've taken in 2.75 kg. $19 on the head. $19 on the head. It's $5 on the low. Still a bit low. I've taken in now 3.2. Maybe the trim pipe charges that we did slightly low. Yeah, that's ramping up now. Let's close that off. 7.4, 5.6, 0.3. Yeah, that's a bit too low. Air off is lovely. Air off 3.7, 3.2. We need the expansion valves to open up in the BS boxes. I was supposed to put 3.5 in it, but it's gone to 3.77. I'll leave it at that. Go check inside. Right guys, come inside just to make sure that all the fan coil units are doing their checks. Fan coil unit on. Fan coil unit on. Oh wow, no difference from before. Oh, sorry. as well. Compressor has cut out like I thought, 3.88 kg. It's fine. Oh, still a bit low. Hey guys, last update for today. You can hear the condenser running behind me. Got it operational. It's in a wiring and piping check test. We have a good old 8.8 on the suction and an 18.5 bar creeping up. We've I just increased the. Let me take the active track off. I just increased the. We're in a small light well here. It's got about 2.5 meters to the top. So I've increased the condenser fan for a high static, so that way we can ensure that the air gets pushed up, the hot air gets pushed up to avoid any short cycling. But yeah, it's sitting nicely. 18.3, 884. I didn't connect the service checker to it yet, but if we do a walk around of the indoor units. Oh wow. Yeah, it's freezing in there. Show you some of the units. And that is all 11 on this floor. Now we've got to go down to the ground floor. We've got 4 there. It's getting there. It's about 7 in the evening. Getting ready to pack up. Condenser's still doing its thing. It's more like it. 8.6, 19.5. Getting there. Hey guys, final visit today at our West Drayton project, VRV 3-pipe heat recovery. I've just come back to connect some of the wall controllers onto it. Now it's going to pass a wiring and piping check, and it has. It's gone into TL3 for the wiring and piping, and you can. Some of the condenser fans were running up. You can see that there. See the video, condenser fan running up. Just as you can hear, one of them is whirring away. Another nice project wrapped up. Daikin VRV4 loop, 3-pipe, 20 horsepower, 15 indoor units, BS boxes, done, installed, supplied and commissioned by yours truly, iClimate. We'll see you on the next one.